I'm Brendan Wilk. I am a software developer at the Hudson Alpha Institute for Biotechnology. I also happen to be a graduate student at the University of Alabama, Huntsville. I'm going to talk to you about our tool PyxisMap, which leverages the powers of the HPO ontology to help us prioritize variants based off of a patient's phenotype. So we had three motivations behind getting this tool, and really this was just me getting angry because we need a more efficient method to prioritize our variants. When you're doing a clinical analysis, the results of the clinical filter end up coming back to be around roughly 300 to 400 variants, so we need a better way for our clinicians to look at that. Naturally, HPO lends itself to that. We needed to provide an interface for the users to explore and acknowledge the phenotype of their patients, and then we also wanted to provide up-to-date references of gene to disease associations in the literature. So this is the workflow for the application. We start with converting the patient's clinical indications, whether it be automated through concept recognition or manual entering by a clinical analyst. We then get a phenotypic description in HPO terms of that. Then we leverage annotations to genes to phenotype from the HPO, as well as gene to disease relationships from a great tool called PubTator, offered by the NCBI. We can then use a random walk with restart algorithm to traverse the graph and determine the association between two nodes within the graph based off the input phenotype of the patient. From that, we can derive a prioritized list of genes for the clinician to look at when doing their analysis. So how did we validate this? We had 101 clinical cases with 174 clinically diagnostic variants, and what we did was we compared the rankings of variants based off of PyxisMap to their original rankings that we based on ISMB codes. And this is the results. On the left-hand side, you can see that the lower values for PyxisMap, which is on the top in both graphs, is lower, which is what we want, which we want a mean and median rank to be far lower, which makes our analyses faster. As well as on the right, you can see a higher number is better because we have the number of variants seen in the top 20 first variants for them to look at is 155, and then the number that ranked first was above 60, meaning that the variants that the clinician needs to see are going to be the ones that come up first, or far sooner in their analyses than otherwise would be. Some of the future directions that we need to go with this is right now we're only focused on human disease, but we didn't plan to incorporate model organism data in here to enrich our human disease annotations. We also want to optimize how clinicians enter their information, the phenotypes, and then also integrate in pathway data. So in conclusion, we have built a web-based tool. If you want to see the interface, please come to the poster and see us. We also will soon have the application available source code as well as a Dockerized application container. This is the URL to our publicly available web server if you don't want to stand up your own instance. Come see me at poster B566. I'd also like to thank my co-developer, Matt Holt, as well as our PI, Liz Worthy. With that, I'll take any questions.
Well, no questions, so thank you very much. So now we have finished this session. We will resume back at 2 o'clock for the next session. If you have a talk already in that next session and you're here, please come up and throw your slide deck up, and we will be ready for the next session. Thank you very much. Enjoy your lunch.